Hey there, chemistry champions. Are you tired of losing easy marks on rate calculation questions? Well, in this explainer, we are going to fix that for good. But hey, first things first, make sure you're subscribed and you've got those notifications turned on. That way you won't miss out on mastering all these WAEC and NECO problems. All right, let's get started. Okay, let's just dive right in. We're gonna look at a classic WAEC style question, the kind that trips up so many students, but not you, not anymore. So here we've got a table. A student recorded the volume of gas that was produced and the mass of the reactant that's left over time. The question looks simple. Calculate the average rate in the first 10 seconds. Seems easy enough, right? Well, let's see. Now, here is a very common mistake. A student calculated, 5.0 minus 4.2, and then divided that by 10, which equals 0.08. I mean, the math is perfect, right? But they still lost all the marks. So what happened? Why? They used the completely wrong quantity from the table. And believe me, this isn't some rare mistake. We're talking about an error that costs students marks in 55% of these questions. It is a huge, huge trap. But don't you worry, because we are going to fix this whole confusion right here, right now. So what's the secret? It all comes down to understanding one single golden rule that just unlocks these questions every single time. Here it is. The key idea that changes everything. Rate is always asking how much of something changed over a period of time. That's it. It's that simple. Rate equals the change in quantity divided by the time taken. But here's the part that trips everyone up. That word quantity is so critical. You have to use the specific quantity the question is talking about. So if it mentions gas volume, you better be focused on that volume column. If it says concentration, your data needs to come from concentration. And if it's about mass lost, you work with the mass figures. You can never, ever mix them up. So to make sure you never fall for this trap again, I'm gonna walk you through a foolproof thinking process that you should use every single time to get this right. Okay, here we go. First, you read the question carefully to figure out what quantity is actually being measured. Second, you find that quantity in your data table and calculate how much it changed. And remember, change is always the final value minus the initial value. Third, identify the time interval, which is just the final time minus the initial time. And finally, step 4, you divide the change by the time, and you always, and I mean always, write the unit. A rate without its units is totally meaningless. All right, let's circle back to our original problem and actually do this the right way, using our brand new 4-step process. So here's our table and question again. Let's apply those steps. Step 1, what quantity changed? The question is pretty general, so we can choose to measure the rate using the volume of gas that was produced. So that's gonna be our focus.
Okay, step 2, what's the change in volume? Well, at 0 seconds, the volume was 0. At 10 seconds, it was 24. So the change is just 24 minus 0, which is 24 centimeters cubed. Simple.
And step 3, what is the time interval? Well, the final time is 10 seconds, and the initial time is 0 seconds. So our time interval is simply 10 seconds. Easy enough? And now for step 4, we calculate the rate. Rate equals the change divided by the time. So that's 24 centimeters cubed divided by 10 seconds, which gives us 2.4 centimeters cubed per second. We use the correct column, we use the correct formula, and we included the unit. That right there is a full marks answer. Now watch this. Same table, same time interval, but a totally different question. This time, it asks to calculate the rate of mass loss. So what do? We use the mass column. The change in mass is 5 minus 4.2, which is 0.8 grams. The time is still 10 seconds, so the rate is 0.08 grams per second. See? This shows the key point perfectly. The mass of the reactant goes down as the volume of the product goes up. There are just 2 different ways of measuring the exact same reaction, and that's why we get 2 different but equally correct rates. You see? The formula stays exactly the same. What changes is the quantity you decide to plug in. This is the big decision that you have to make every single time. Okay, you've seen how it's done. Now it is your turn to apply this exact same thinking process. You got this. Here's a brand new problem for you. This time, a student is measuring concentration every 5 seconds. You've got the time and you've got the concentration data. So, without me showing you the answer, How would you calculate the rate between 0 and 5 seconds? Think it through. I'll give you a moment. 3, 2, 1. All right, let's walk through it together. Did you get it? 1. The quantity is concentration. 2. The change is 2.0 minus 1.6, which is 0.4. 3. The time interval is 5 seconds. And 4. The rate is 0.4 divided by 5, which gets you 0.08 moles per decimeter cubed per second. If you followed that structure, you are absolutely ready for any rate question WAEC can throw at you.
Great work! Seriously. Let's do a quick review of everything you've just mastered, just to lock in that confidence.
Look at this. You can now confidently identify which quantity to use from a data table. You can calculate the change correctly using final minus initial. You know how to find the rate using the core formula, and you know to write your answer with the correct unit. No more losing marks on these simple mistakes. The next time you see this question in your exam, you'll know exactly what to do. Hey, if this explainer helped clear things up for you, do me a favor and hit that like button, share it with your classmates, and of course, subscribe to Tailspire Learning so you can stay ahead in your WAEC and NECO prep. I'll see you in the next one.